السلام عليكم يا شباب، ازيكم عاملين ايه؟ يا رب تكونوا بخير وصحة وسعادة. Today we will start answering the book Avogadro 2024 chapter 1 transition element lesson 1 from question number 36 to question number 66. The question said all the following elements are main transition element except. The word except meaning that you have 4 choices and you will choose the wrong one. Okay? Always except means that you have 4 choices, A or B or C or D, and you will choose the wrong one. So, to know some notes, important notes, that when electron configuration for F sublevel maybe 4 or maybe 5 is completely filled with 14 electron, and a D sublevel filled with electron in sequence from 2 electron to 10 electron, this electron configuration belongs to main transition element. And any electron configuration end with D sublevel, so it belongs also to main transition element. On the other hand, if the electron configuration end with sublevel F, maybe 4 or 5, whatever the difference in principal quantum number, and filled with electron in sequence from 1 electron to 14, maybe 1, maybe 2, maybe 3, whatever, until reach to 14 electron, and D is only contain 1 electron, so this electron configuration belongs to F block element, which called inner transition element. So, to look on our choices for S235, this electron configuration ends with D, so it belongs to main transition element. Choice number B, the electron configuration ends with 4F14 and 5D1, and this resemble with this electron configuration which belong to the inner transition element, so that electron configuration not belong to main transition element. Choice number C, 4F14, 5D2, and when D filled with electron in sequence from 2 to 10, so it's belong to main transition element, and when electron configuration end with a D electron, a D sublevel contain any electrons, so it also belong to main transition element. So our choice or wrong choice will be choice number C, because it belongs to inner transition element. Question number 37, the electronic configuration of a transition element's ion lies in the first transition series, in which sublevel 3D become completely filled with before sublevel 4S, and this condition will appear or will achieve in one element in our first transition series. What this element? Cu29, copper 29, with electron configuration argon 18, 4s1, 3d10, and that we mentioned before, copper and chromium has anomalous electronic configuration to achieve extra stability for their atoms. Okay, in this condition, 4s1 is half filled, but 3d is completely filled. So in copper, 3d become completely filled before 4s become filled. He asked in the question about ions. So we mentioned before, ions in first transition series must be electronic configuration 4s sublevel contains 0 electron. So when I talk about ion, I will look for 4s0. Okay, 4s1, no, wrong. 4s1, no, wrong. 4s1, wrong. Yes, 4s0, excellent, because copper have 2 oxidation state, positive 1, and 4s will be 0, 3d still 10, or positive 2, 4s also will be 0, 3d will be 9. So the electronic configuration right about ions in the free transition series is 4 is 0. I look for firstly for sublevel S0, for sublevel S0. So the right choice, letter number C. Question number 38. An element in period number 4 and the column number 12 in the periodic table. So the electronic configuration of its ion is. We should look for this location in our periodic table. He said period number 4 and group number 12. So the element will be zinc 13. Atomic state configuration argon 18, 4s2, 3d10. But in the question asked about its ion. So it have one oxidation number, zinc positive 2. So it will be argon 18, 4s0, 3d10. So the last electron configuration for zinc plus 2 will be 3d10. So the correct choice is letter number B. Question number 39. Which of the following contains the largest number of unpaired electrons in sublevel D? So we should divide our artboard and take all our choices. Choice number A, Zn30 in atomic state. We will firstly make electron configuration for the atomic state, then we will make the electron configuration for each oxidation state he asked in the questions. Argon 18, 4s2, 3d10. He asked about zinc positive 2, so electron configuration will be argon 18, 4s0, 3d10. We will draw the d orbital and make distribution for our 10 electron. It will distributed unpaired firstly 1, 2, 3, 4, 5. Then pairing will be occur 6, 7, 8, 9, 10. He asked in the largest number of unpaired electron. In 3d10, no unpaired electron. Choice number B. Firstly, we'll make electron configuration for iron 26, argon 18, 4s2, 3d6. So he asked about oxidation state positive 2 will be argon 18, 4s0, 3d6. We will make electronic distribution in our d orbitals. Unpaired electron distribute first 1, 2, 3, 4, 5. Then pairing occur 6. He asked about the unpaired electron, so we have 4 unpaired electron. 4 unpaired electrons. Choice number C. Zinc in its atomic state, argon 18, 4s2, 3d10. Make electronic distribution in our d orbitals. It will be 1, 2, 3, 4, 5. Then pairing take occur 1, 2, 3, 4, 5. So there are 10 pairing electron. So there is no paired electron. Choice number D. Iron 26, argon 18, 4s2, 3d6. He asked about electronic configuration for iron positive 3. It will be argon 18, 4s0, 3d5. Draw the d orbitals. make electronic distribution 1, 2, 3, 4, 5. Then pairing take place. Okay, no, they are only 5 electrons. So we have 5 unpaired electron. 5 unpaired electron. So he asked about the largest number unpaired electron. It will be 5 unpaired electron in a choice iron +3, letter number D. Question number 14. Which of the following pairs of transition elements contains the same number of unpaired electron? Okay, we will take our choices individually. Choice number A and choice number B. Choice number A contain 2 electrons. 2 elements. Elements number 1, vanadium 23. Elements number 2, cobalt 26. Electron configuration for vanadium, argon 18, 4s2 3d3, have 3 unpaired electrons. Cobalt 27, argon 18, 4s2 3d7, and electron configuration for 3d7. We will draw d orbitals and make electronic distribution. Unpaired firstly, then pairing take place. 6, 7. So we have 3 also unpaired electron. So in choice number A, vanadium 23 and cobalt 26, they have the same number of unpaired electrons. Choice number B, we have scandium and copper. Scandium 21, electron configuration, argon 18, 4s2 3d1. It have 1 unpaired electron in d orbitals. Then copper 29, electron configuration, argon 18, 4s1 3d10. It has 1 unpaired electron but in s sublevel orbitals. So they also have the same number of unpaired electrons. Choice A correct, choice B correct. Let's take choice C. In choice C, we have titanium 22 and nickel 28. The electron configuration for titanium Ti22, argon 18, 4s2 3d2. Draw the orbitals. We have only 2 electrons, so it has 2 unpaired electrons. Nickel 28, electron configuration, argon 18, 4s2 3d8. Draw the d orbitals and make electron distribution. Unpaired firstly, we have 5 unpaired, then pairing take place. So we have also 2 unpaired electron. So choice number A, they have the same number of unpaired electron. Choice number C, B, they have the same number of unpaired electron. Choice number C, they have the same number of unpaired electron. So all the previous choices are correct. So the letter D is the correct choice. Question number 41. If you know that the outer electronic configuration of ion of the element X is X3PO4 pi2 S3D6. So the element contains in orbitals of 3D. He gave us the electron configuration of 3D6 and he asked about the number the element contain in orbital of 3D, how many electron in 3D. Okay, we will draw our 3D orbital and make electron distribution. 6 electron, 1, 2, 3, 4, 5, 6. How many electrons in 3D? 6 electrons. It's a simple question, so the right choice is choice number A. Question number 42. If you know that X and Y are two metals, X is a transition element in period 4. Okay, X transition element, and form an alloy with nickel. That our alloy. And Y the transition metal can form compound with Y Cl7. Y Cl7. That means oxidation number of Y is positive 7. Which one of our element in the first transition series can produce oxidation state positive 7? We notice that manganese 25, only one who could make oxidation state positive 7. So we know that now Y is manganese 25. So manganese 25 has two alloys, one with an iron and one was aluminium. Aluminium not located in the period number 4, it's period number 3. So we will make exception for aluminium. Manganese make an alloy with iron, it's called ferromanganese, used in railway track because it hardens than steel. Its properties hardens than steel. Okay, we know that manganese 25 from its oxidation state. So manganese has two alloys, one with iron, it's called ferromanganese, it's used in railway tracks, and it's harder than steel, and with aluminium, but we will exception aluminium because he asked about period number 4. So our correct choice is choice number A, more hardness than steel. Question number 43. The element whose electronic configuration in SPI argon 18 4s2 3d8 is found in the periodic table. So he asked about the location. And to achieve our location, we should search about two sides. The first one, we should know the period, number of the period, and the number of the group. Number of the period calculated from the highest number besides S sublevel. So S sublevel is 4s. The highest number is 4, so the element located in period number 4. And the group, if your d orbitals end with 6 or 7 or 8 electron, that locate in 8 group in our periodic table. So it located in 8 group number 8 and period number 4, which achieved in group in choice letter D. As we see in our periodic table, group period number 4 and group number 8, it's nickel 28 that located in the group number 10 because number of electron of S and D is 2 plus 8 equal 10. So the element located in column number 8, column number 10 and group number 8. So the choice is correct is choice number D. Question number 44. From the following table, we have the element on section and the description in the other section. Okay, element A lie in the first transition series and column number 10. We should take a look on our periodic table. He said in the first transition series from scandium to zinc, and in column number 8, so it's nickel 28. So we know that the element number A is nickel 28. Element number B. In element number B, it has most important note you should take in consideration. مهمة جدا النوتس دي قوي، انها بتبدأ تعمل explanation للunpaired electrons in our first transition series. Okay, B positive 2 contains 3 unpaired electrons, and the B positive 3 contain 4 unpaired electrons. So it will be, we should draw our d orbitals. He asked in the question بيسألني ان ال B positive 2 contain 3 unpaired electrons. So هنبدأ نعمل electronic description. 3 unpaired electrons, that means that maybe 1, 2, 3, and or it may be 1, 2, 3, 4, 5. بعد كده البيرنج يحصل 6, 7, and in these two conditions we have 3 unpaired electron, and here we have 3 unpaired electron. So this electronic configuration is 3d3, and the 4s will be 2. So the element, the first, may be vanadium 23, or when 3d contains 7 electrons, it may be cobalt 26, which electronic configuration 4s2 3d7. بعد كده بقى الجزء الفاينل ريزلتس بتاعتنا هتكون معتمده على التشويس او على السنتنس نمبر 2 اللي هو بيقول فيها B positive 3 contain 4 unpaired electrons. يعني دلوقتي لما يبقى in positive 3 when low 3 electrons contain 4 unpaired electrons, that means the number of paired electrons increase. We should apply this for vanadium 23 and apply this for cobalt 27. So vanadium 23, but vanadium positive 3, 4s equal 0, 3d equal 2. So it has 2 unpaired electrons. And he tell me in the question it has 4 unpaired electrons. So it's not a vanadium. We would make exception for the vanadium. But when we apply this for cobalt 27 in positive 3, 4s will be 0, 3d will be 6. Make description for the electron configuration 1, 2, 3, 4, 5, and the pairing take place 6 electrons. So it has really 4 unpaired electrons. So the element number B will be cobalt 26. So we know that the element A is nickel 28 and the element B is cobalt 27. So the element C will be, he tell me that the description non-transition element in the first transition series. Non-transition element in the first transition series, it will be found in 2B group. As we see in our periodic table, 2B group is not an transition element. So he asked especially in the first transition series, so it will be zinc 30. But we know that element C will be zinc 30. Element D, he gave me description, said lie in period number 5, group number 6p. Period number 5, sorry, and group 6p. Okay. Take a look in our periodic table. He said group number 5, period number 5, period number 5, and group 6p. So it NB41. NB41, if you look at that, الجزئية دي مش مطبقة عندنا في المنهج قوي، النوبيوم، بس النوبيوم عنده شذوذ أو بنقول عليه anomalous electron configuration. So D it's at NP41. 41. So he asked in the question, the element which has abnormal electron configuration or anomalous electron configuration, abnormal electron configuration than the other element, it will be D. And this part is not applied in your chapter. الجزئية دي للأسف مش عليكم، هي السؤال ده خارج بره المنهج شوية. Nubium 41 really has abnormal electron configuration. And with exception ممكن نجيبه بالexceptions عادي. عارفين إن nickel 28 is normal electron configuration, cobalt is normal electron configuration, zinc is normal electron configuration. So the one that has abnormal electron configuration, it will be choice number D with exception solution. Question number 45 for the following table. The first section element or ion, the second section electron configuration. A argon 18 electron configuration argon 18 4s2 3d1, so it's element scandium 21. Element B lose 3 electron, return 3 electron back, so it will be P0 in its atomic state. So the 3 electron will be back, 2 of them will be in 2s and 4s, and 1 will be in 3d. So 4s2 3d4 electron configuration, it's abnormal. 4s1 3d5, so B it's chromium 24. C positive 2, and it has a good idea in this choice. C positive 2 xenon, (54). I will let a space in this, I will tell you later. 4f14 5d10. So this ion is lose 2 electron, returns 2 electron back to this atom in its atomic state. The 2 electron will be put in s sublevel, so 5s sublevel, 5s2. So make assumption for all electron in this electron configuration for C in atomic state, not in atomic state positive 2. So it has 54 for the atomic noble gases, plus 2 in S sublevel, plus 14 in F sublevel, plus 10 electron in D sublevel. The whole summation will equal 80 electrons. And 80 electrons in our periodic table refer to mercury element. So the choice C will be mercury element. He asked that the mixture of the element A with element C is used in. Okay, element A plus element C. Element A scandium plus element C mercury. So they will make a mercury vapor lamps. An alloy used in making McFighter jets? No, McFighter jets, scandium plus aluminium. Mercury vapor lamps, excellent. But the right choice is letter B, mercury vapor lamps. Sun protection cosmetic for titanium dioxide, so it's wrong. An alloy used in making space shuttles, titanium with aluminium, and also wrong. As we said before, right choice number B. Question number 46, which of the following contains the highest number of unpaired electrons? We have 4 choices, and we will divide our board into 4 sections, A, B, C, D. Okay, choice number A, magnesium positive 2. So magnesium electron configuration will be 1s2, 2s2, 2b6, 3s2. So it has no unpaired electron, no unpaired electron in S sublevel. Choice number B, titanium positive 3. We will make it in its atomic state firstly. Titanium argon 18, 4s2, 3d2. he asked about oxidation state positive 3. So we will lose 2 electrons from 4s, then 1 electron from 3d, then draw electronic configuration in d orbitals with 1 electron. So it has 1 unpaired electron. Choice number C. Fe positive 2. Firstly, we will make electronic configuration for iron in its atomic state. Fe26 will be argon 18, 4s2, 3d6. He asked in the question about oxidation state positive 2, so it will be argon 18, 4s0, 3d6. The orbitals, we will make electronic distributions. Unpaired firstly, then pairing electron will take place. So we have 4 unpaired electron in Fe positive 2. Choice number D. Vanadium 23, we will make electronic configuration firstly for the atomic state, argon 18, 4s2, 3d3. He asked about oxidation state positive 3, lose 2 electrons from 4s, then 1 electron from 3d. Draw 3d orbitals, make electronic configuration, 1, then 2, so we have 2 unpaired electrons. He asked in the text of the question to the highest number of unpaired electron. Highest number of unpaired electron achieved in case Fe positive 2 and choice number C. So the right choice will be Fe positive 2. Question number 47. X, Y are two transition elements of the first transition series. Each can be used in metal plating. Okay, so it will be easy. The two elements that used in metal plating, one of them is chromium 24 and the other will be nickel 28. The most common two elements used in metal plating in the first transition series. Okay, let's make our electron configuration for chromium 24 and nickel 28. We know that chromium 24 has abnormal electronic configuration. Argon 18, 4s1, 3d5, s contain 1, d contain 5. And for nickel 28, argon 18, 4s2, 3d8. Draw our orbitals. S contain 2 electrons, d contain 8 electrons. So let's continue reading our question. If the number of the electrons in outer main energy level, he referred to main energy level. Main energy level means that for is outer main energy level, it refers to 4s. So let's make a highlighter for our 4s. Okay, then continue reading. X is less than the number of electrons in outer main level. X is less than. How many electrons in 4s1? 1 electron in outer level. How many electrons in outer level in nickel? 2 electrons. Which one is less chromium? So chromium will take symbol X. And nickel will take symbol Y. So he asked about the element Y. So it will be nickel 28. Because you know that the outer energy level, main energy level will be 4s, contain 1 electron, and in nickel 28 contain 2 electron. And he mentions that the X is less than the number of the electron from Y. So X will be chromium 24 and nickel will be element Y. So our choice will be A. Question number 48, the element that electronic configuration of its divalent ion. Divalent ion means that positive 2 oxidation number means that lose 2 electron. Ends with Q36 4D10 is used in manufacture of. To know the manufacturing of this element, firstly you should know its atomic number. From atomic number you will know which element he asked about by returning it back to its atomic state. So the electronic configuration Q36, we will let space and then write 4D10. Okay, we will bring back 2 electron and this 2 electron will be put in 5s2. So to know the atomic number, we will make summation process by 36 electron plus 2 electron in S sublevel plus 10 electron in D sublevel. Summation will be 48 electron. So the element with 48 electron is cadmium, located in group 2b in our periodic table. Okay, so we know that the cadmium used in battery was nickel. Which one of this advantage is rechargeable. So we know that it's a cadmium element which used in make a rechargeable batteries with nickel. So highly conductive magnets, no. X-ray screen, no. Rechargeable batteries, yes. So the choice will be C. Question number 49. Which of the following compounds can be used in disinfection of chicken farms? Disinfection, you should use antiseptic substance for make disinfection. So antiseptic substance is one substance we studied, KMNO4, which called potassium permanganate. So the right choice will be choice number C, potassium permanganate. Question number 50. Which of the following compounds can be used in spraying plants to get rid of pests? Okay, you need fungicide substance. And the fungicide substance will be in 2 compounds in our first transition series, magnesium disulfate and copper disulfate. So choice number A right and choice number B is right. This question need to be rewrite. Okay, but choice number A is correct and choice number B is correct. Question number 51. The color of glucose solution. We have a test tube. We will put glucose solution and then added filling solution. We know that the filling solution color is blue. Filling solution color is blue. So when you put filling solution color on the glucose solution color, the whole color in the end of this reaction will be changed from blue to orange as a detection process for the glucose solution. So the choice number A will be the correct one. Question number 52. The number of the electron in sublevel 3D in 26 x positive 2 is equal to the number of electron in the all following except. Except means that we have one choice is wrong and we will choose it. The meaning of word except in our question, that means we have four choices and we will choose the wrong one. Okay, firstly we should know how many electron in 3D sublevel in x positive 2. Okay, x positive 2, 26, argon 18, 4s will be 0, 3D will be 6. So we have 6 electrons in sublevel D. So let's apply this condition to all our choices. Now we know that the electron in 3D will be 6 electrons. So choice number A and choice number B. Choice number A, the number of electron of B sublevel in neon Ne10. Ne10, 1s2, 2s2, 2b, 6. The B sublevel in neon contains 6 electrons. Okay, and that is compatible with 6 electron for the text of our question. اختصار يعني 3D هنا فيها 6 electron والB فيها 6 electron برضه. فالchoice number A is correct. واحنا قلنا هنبحث ونعمل سيرش على الchoice اللي هيكون wrong. Choice number B, number of electrons of D sublevel in F26. Okay, F26 will be argon 18, 4s2, 3d6. So the D orbital contains 6 electrons, the same as the ion x positive 2. So choice number B is correct. Let's take choice number C and D. Choice number C, number of electron of B sublevel of outer level in an element of atomic number 34. Atomic number 34, we will represent the element with symbol X, 34. So electron configuration will be argon 18, 4s2, 3d10, and 4b4. To achieve or to make electron configuration for 34, it will be 4s2, 3d10, 4b4, and when you make a summation process for this electron, 18 plus 2 plus 10 plus 4 equal 34. So as we know that in the text of the question, we mentioned that the number of electron will be 6 electron. So, and the number of electrons choice C is 4 electron. So there is no quality between them, 4 electron and 6 electron. So they are not the same electron. So the choice number C is the wrong one, and we will choose the choice number C. Choice number D, number of the electron in the last P sublevel of chlorine minus 117. Okay, chlorine 17, electron configuration will be to the nearest noble gas, neon E10, 3s2, 3p5. And when gain 1 electron, 3b will contain 6 electrons. So we have 6 electrons in the choice C and 6 electron in the text of the question. So the choice number D is the correct one. And we know that when asking about the except, or when mention except word in our question, that means that we should choose the wrong choice from our choices. Okay, so the choice we will choose will be number C. Question number 53. The following are used in making batteries except mean choose the wrong one. Magnesium dioxide, yes, is used as oxidizing agent in batteries. Cadmium with nickel make rechargeable batteries. The element precede nickel in its series. It's cobalt 27, and we will study it in the chapter number 4, electrochemistry, in dry batteries as lithium ion battery. And choice number C is correct. Titanium not involved in making batteries, so we will choose letter D. Question number 54. The element which its divalent ion ends with the electronic configuration argon 18 3d2 is used in. He gives us the electronic configuration for ion, and to know the element you should return it back to its atomic state. So return the 2 electron, as he mentioned, divalent, that means he lost 2 electrons. So you bring the 2 electron back to its sublevels. So he in X positive 2, argon 18, 3d2. So return back to its atomic state, return 2 electrons, it will be argon 18, 4s2, 3d2, and this element is titanium 22. So let's know that the uses of titanium and choose one of these choices. Dental implanting, excellent, it's correct. Laser tanning, no. Chromium used in laser training. Making rechargeable batteries, no. Nickel cadmium, so it's wrong. Making magnets, no. Iron, so it's wrong. So we said before that the letter number A is the choice 1, right choice 1. Question number 55. 2 compound XO2 YO2 if the number of the half-filled orbitals in the 3D sublevel. You should focus in this sentence. 2 compound XO2 YO2 if the number of half-filled orbitals in 3D sublevel of X. Okay, half-filled orbitals in 3D sublevel of X equal the number of 3D orbitals. Okay, that means the number of 3D orbital is 5 orbitals. 5 orbitals in 3D. Okay, and he mentions that the number of orbitals in 3D equal the number of half-filled in element X. Half-filled orbital in element X. So that means in 3D in X contain 5 electron. 3D contain 5 electron and proceed with 4s2 and proceed with argon 18. So that element will be manganese 25. Okay. The second part of this question. and the number of vacant orbitals of 3D of the element y equals 3. That means y have 3 vacant orbitals. That means that have 2 orbitals half filled. Okay, draw 3D orbitals. The orbitals have 5 rooms. So he said that 3 vacant orbitals. We will let 3 orbitals vacant and we will put 2 electrons here. So that means that when the 3 vacant orbital is found, that means the other 2 orbitals is half filled with electron. Okay, so that means 3D equal 2 and proceed with sublevel for S2, proceed with argon 18 electron configuration. So this element will be titanium 22. So I know that in Y refer to titanium 22, X refer to manganese 25. He asked about oxides. So the most common oxide for manganese is MnO2, manganese dioxide, which used in dry cell as oxidizing agent. And the most common oxide for titanium, TiO2, which used in sun protection. So let's read our choices and see what's the right and what's the wrong. Compound XO2, which mean MnO2, is used in making dyes? No, it's wrong. So choice A is wrong. Compound XO2 is used in making sun protection. We refer that it's MnO2. In sun protection, no. That المفروض suppose that titanium 22 in oxide TiO2, it's used in sun protection, not MnO2. Choice number C. XO2 refer to MnO2 is used in making dry cell. Yes. Compound YO2 refer to TiO2 used in making sun protection creams. Yes. So the right choice is choice number C. Question number 56. The two elements Cu, chrome are similar in. Let's make our electronic configuration. Chromium 24, argon 18, 4s2, 3d4. No, it's abnormal. Electronic configuration will be 4s1, 3d5, and electronic configuration for copper 29 will be argon 18, 4s1, 3d10. Draw our sublevel orbitals for S, for D, for S, and for D. Okay, S contain 1 electron, D contain 5 electrons, S contain 1, and D contain 10. 1, 2, 3, 4, 5. Then pairing will occur 6, 7, 8, 9, 10. Okay, let's read the choices. The number of unpaired electron, 6 unpaired electron in chromium and 1 unpaired electron in copper. So choice number A is wrong. The number of paired electron, chromium 0 unpaired electron, not have any paired electron, and copper has 10 paired electron. So choice number B is wrong. Choice number C, number of occupied orbitals with electron. Occupied orbitals mean filled orbitals, completely filled, or half filled orbitals. So let's go. That means consumption of all orbitals you have. We have here 6 occupied orbitals, and also we have here 6 occupied orbitals, because we know that either half filled orbital or completely filled orbital, it's called occupied orbital. So it's occupied, 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 occupied. We have 6 occupied, and on the other hand also 6 occupied. So the choice number C is correct. The number of occupied orbitals with electron. Choice number D, number of proton. No, number of proton in chromium 24. And number of proton in copper 29. So it's wrong. And we said before that letter number C is right. Question number 57. The element used in making shoes. Making shoes, he means that laser tanning. So the element used in laser tanning is chromium 24. He asked about the location of the chromium in periodic table. In chromium, as we mentioned before, in the group 6p, because chromium configuration, argon 18, 4s1, 3d5, 1 electron in S and 5 electron in D, so it's 6b electron, and 6b electron located in column number 6. As we see in our periodic table, chromium in group number 6 in the column number 6, because 1, 2, 3, 4, 5, and he located in the 6th column in group number 6. So the right choice will be choice number B. Question number 58. The element that used as a catalyst in the conversion water gas to the liquid fuel. This element is iron 26. Okay. And this method known as Fischer-Tropsch method. Tonic configuration for iron 26 will be argon 18, 4s2, 3d6. Draw sublevel s orbitals and sublevel d orbitals and make electronic configuration distribution. 4s2 contain 2 electrons, and 3d will firstly be unpairing electron, then pairing will occur. Okay, let's read. Contains how many complete field orbitals in 3d sublevel? Complete field orbitals which have 2 electrons only, not 1 electron. So he asked in specific 3d sublevel, so we should focus about 3d sublevel. How many orbitals in 3d sublevel has 2 electrons? Yes, 1 orbital only in 3d sublevel, which has completely filled orbitals, so it's choice number B. Question number 59. To preserve perchloric acid, which chemical formula HClO4, we use an alloy of K. When he mentioned the acids, you should take in consideration alloy nickel with steel in choice number B, which is properties hard, resist rust, and effect of acids. So the choice number B is the right one. Steel and nickel used to preserve perchloric acids alloy. Question number 60. To overcome weakness of aircraft's frames due to friction with air. Friction with air, we can use alloy. In aircrafts, the most common alloy between titanium, and aluminium. So the right choice is choice number A. Question number 61. The liquid battery has many disadvantages. This problem is solved by using other rechargeable batteries. Okay. Focus on this word, rechargeable batteries. The elements that are used them lie in. Okay, you need to know the location of this element. So rechargeable batteries consists of nickel 28, cadmium 48. Okay, and the nickel located in group number 8 in periodic table, and cadmium in group 2b, and follow zinc in the group. As we see in our periodic table, cadmium in group 2b, the nickel in group 8. So the choice will be number C, group 8 and group 2b. Question number 62. The beachgoers suffer from the extreme heat of sun. Beachgoers, people who go to the beaches in the summer. اللي احنا بنقول عليهم يعني رواد الشواطئ. تمام؟ Suffer from extreme heat of sun. There is a problem with the sun. So to avoid this problem, we use sun blocks. And sun blocks, problem using cosmetics, contains the transition element ion. Always transition element ion, which used in cosmetics, especially in sun blocks creams, is titanium dioxide, which oxidation state in this compound will be titanium positive 4. So the right choice will be choice number B. Question number 63. Person suffer from tumor in thyroid gland. When the doctor check him, he doubts that he may suffer from diabetes, يعني السكر. So the doctor do analysis that confirm his doubts. Then the doctor determined at the time to do a surgery to remove the tumor. Answer the following in view of what you studied. The doctor made sure that the sugar is found in urine using a solution that contain. We know that the detection of sugar is determined by Fehling solution, which is one of copper compounds. So the solution contain copper only. So the right choice number D. Section number B for the question 63. Here is the same text, but the demand is different. The element used in making surgical tools. Surgical tools, it's one element is used in that. It's iron 26. He asked about its most stable ion. Most stable ion for iron, it will be iron positive 3 with electronic configuration argon 18 4s0 3d5. So the right choice is choice number P, argon 4s0 3d5. Section number C for question 63. The same text also. The doctor has to find alternative method except surgery to treat the patient. Patient has tumor. So the alternative treatment with tumor is radioactive treatment, which help us to overcome or get rid of the tumor without any surgical process. So we will use radioactive cobalt to destroy or get rid of the tumor in the choice number P. Question number 64. From the opposite table we have two sections, section for ions and section for electron configuration. So firstly we should return ions to its atomic state. X positive 2, that means lose 2 electron, return 2 electron. It will be 4s2, 3d8, and this electronic configuration, especially for nickel 28. Y positive 3, return it back to its electronic configuration, will be 4s2, 3d4, and this will be abnormal electronic configuration. It will be changed to 4s1, 3d5 to make extra stability for this atom, and this belongs to chromium 24. Z positive 4, neon 3s2, 3b6. You should bring back 4s and 3d, and it will be neon 10, 3s2, 3b6, and return back 4 electron will be 4s2 and 3d2. Okay, so Z refer to titanium 22. So we have nickel, chromium, titanium or titanium, the alloy of element X with element Y. X refer to nickel plus Y, chromium. So the alloy of nickel chromium used to make electric ovens, furnaces. Choice number A is the correct one. Section number B in the same question, we know that X is nickel, chromium, and titanium. The most stable ion of this element is most stable ion, which has all completely filled sublevel with electrons. So which of one have the most completely filled sublevels? It will be Z positive 4, neon, that have all orbitals completely filled, and 3s and 3b filled with all number of electrons. So the most stable it will be Z positive 4 because it has all completely filled sublevels in their electronic configuration. Section number C, for the same question, we know that X is referred to nickel, Y is referred to chromium, Z is referred to titanium. He asked about the element that follow Z in each series. Z referred to titanium 22, and the element that follow titanium 22 is vanadium 23. So vanadium 23 used with steel in to make alloy that used in car spring, as we studied in the lesson. So the right choice will be letter C. Question number 65. Which of the following contains the least number of unpaired electrons? Okay, we have 4 choices. Divide our board. Let's take the first one, choice number A. Manganese 25. Make electronic configuration. Argon 18. 4s2, 3d5. He asked about oxidation state positive 2, so it will lose 4 electron from 4s, then 3d will be 5. Make electronic disruption 1, 2, 3, 4, 5. So it has 5 unpaired electron. Choice number B, asked about titanium 22, argon 18, 4s2, 3d2. And the choice he asked about titanium positive 3, so it will be 4s0, 3d1, disruption 1 electron, distribution 1 electron for 3d. So it has 1 unpaired electron. Okay, choice number C, refer to iron in atomic state 26, argon 18, 4s2, 3d6. So he asked about oxidation state positive 2. It will be for S0, 3d6, make electronic disruption 1, 2, 3, 4, 5, then 6 electrons. So it has 4 unpaired electron. Choice number D, vanadium 23, argon 18, 4s2, 3d3. He asked about oxidation state positive 3. So it will be for S0, 3d2. For electronic disruption and distribution in d orbitals, it will be 1, 2. It has 2 unpaired electrons. And he asked in the question about the least number of unpaired electrons. So the least number in choice number B, which has 1 unpaired electron, and refer to titanium in oxidation state positive 3. Question number 66. If the outer electronic configuration of an element is n-2 F14, n-1 dx, n is 2. If you know that n equals 6, apply this for this equation. N equals 6, that means 6 minus 2 F14 and 6 minus 1 d, and 6 is 2. And if you know that x equals 3, so d contains 3 electrons. That means 6 minus 2, 4f14, 6 minus 1, 5d3, and 6 plus 2. He asked about the location of this compound. As we know, 5d3, as we explained this important note in the previous questions, when we said that when 4f sublevel contain 14 electron and filled with 14 electron, accept it and work on 6s2, work on s sublevel and d sublevel. So 6s2 and 5d sublevel, that help us to know the location of our element that located in the d block element, and to know the series that element located in, we minus the principal quantum numbers, highest principal quantum number for D minus of S minus 3. 6 minus 3 will be 3. So this element located in the third series in the D block element. We take the highest principal quantum number besides the S sublevel and minus it from the 3 to know the location of the series. As we know that the difference between the number of the period and the number of the series is 3. So when you have the number of the period minus it from 3, you will achieve the number of the series. So 6 minus 3 equals 3. If you in the period number 5, 5 minus 3, this element will be in second series. And 4 minus 3, 1. So the element will be in first series. Okay, so this element located in the third series as we studied. So the right choice will be choice number C from the third transition series. وكده الحمد لله يا شباب انتهينا من حل الجزء الثاني من chapter 1 lesson 1.